Hi, 8th graders. It's Mrs. Thompson one final time in section 4.9. This is example 5, and we're going to be writing equations for parallel and perpendicular lines from given information. Now, I will go ahead and note for you, this is definitely state test topic right here. You're going to see, I don't know how many questions, but at least a couple that are going to ask you to do this particular skill. So we're going to spend extra time on this. This video will be a little bit longer than normal, and of course I won't pile drive you with a lot of video watching in one night, so we'll probably have to split this up. So example 5, writing equations of parallel and perpendicular lines. Let's take a look at the very first one, letter A, and this is what it says. Write an equation in slope-intercept form. So right off the bat, we know that our final product needs to be y equals mx plus b. So write an equation in slope-intercept form. That's your final product. We may be able to write it directly in that form. We may have to bypass it and do a couple of other things first before we get there. So let's just see what we're given. All right, now we know that our line passes through the point 4, 5. We know that our line that we're trying to find the equation for goes through the point 4, 5 and is parallel to the line described here, y equals 5x plus 10. So what do I know? What am I given? I know a point on my new line, 4, 5, and I know that my line is parallel to this equation, to this particular line, y equals 5x plus 10. Now the given point, that's not that big of a deal. We could graph that and actually show that on the graph if we wanted to. I don't really want to waste time doing that. But where I want to focus my attention is right here on this piece of information. Our new line that we're trying to find the equation to, our new line is parallel to y equals 5x plus 10. This equation is very, very useful to us. We have one piece of information we need to glean from it that's going to help us find this new equation. Okay? Now think back. Example 1. Mrs. Thompson told you some very important information about parallel lines. They have the same what? Now, if you said slope, you're exactly right. Your eyeballs should be focusing in on the 5. The slope of that line is 5. We need this information because our line is parallel to this given line here. That means if they're parallel, they have the same slope. So I need the point 4, 5, and I also need my slope, which is 5, and I can write an equation. Now there's a couple ways we can do this. One of our guys said, hey, could I just plug into y equals mx plus b? I know I don't know b, but x is 4, y is 5, and could I plug in that way and find b? Absolutely. You can do it this way. 5 times 4 is 20. Subtract 20 from each side, and you're going to get b is negative 15. And so if we use our slope, 5, and now we know what our y-intercept is, here's your equation you would write. There's the equation of my new line. Notice it has the same exact slope as the given line that they said was parallel to my new line. And I just figured out what my y-intercept was. That was one strategy for finding it. Okay? You don't have to do it that way. I know some of you wanted to use the point slope form. So instead, you could plug your information into point slope form and then do your 2 steps that I taught you. Remember, it's always 2 steps to get from point slope to slope intercept. First, distribute. Second, get y by itself. And you're going to get the exact same answer. If you don't, you did something mathematically incorrect, okay? So either way, whether you decide to just plug in the slope-intercept form, plug into y, m, and x, solve for b, and then you can plug in the m and the b once you know both of them, or go right into point slope form, rearrange it to slope intercept. Either way, you're going to get the right answer. Okay, so that's example 5A. Now let's look at 5B. This time they want us to write an equation in slope-intercept form for the line that passes through 3, 2 and is perpendicular to the line described by y equals 3x minus 1. Okay, so what do we know this time? Well, what was given is our new line crosses through 3, 2 and is parallel to this line, excuse me, not parallel, perpendicular to y equals 3x minus 1. Okay, now let's take a look here, because we need, this slope is useful to us, but since it's not a parallel slope, the answer is not 3. If they were parallel lines, we could use slope equals 3 in our new line, but that's not the case. So as you may recall, I taught you in the last two examples about opposite reciprocals. Okay? This becomes very crucial, especially in this particular example when you're trying to find the other slope. Because you can't use 3, the slope is not 3. You can only use 3 if your lines are parallel. Our lines are perpendicular. So what I need to know is, what is the opposite reciprocal of 3? Now, first of all, 3 is positive, so my new slope must be negative. Okay, so that's positive 3, then my new slope has to be negative. Now 3, written in fraction form, is 3 over 1. So that means the reciprocal of 3 over 1 is 1 over 3. That, my friends, is the slope you need to use. That's the perpendicular slope to 3. Okay, so now you have some choices. You know the slope, negative 1/3, and we know a point, 3, 2. And I really don't care which method you use. You can use the method where you plug right into y equals mx plus b and solve for b. So that gives you 2 equals negative 1 plus b, add 1, and b is 3. Okay, you can do it that way, or some of you, I think, prefer the point slope form where you go y minus 2 is equal to negative 1/3 times x minus 3. You distribute, and then you add 2 to each side, and you end up with y equals negative 1/3 x plus 3. You would get that here as well. You just have to rewrite it. M is negative 1/3 and b is 3. You're just going to have to go one step further to write that out, and then you can finish it up. Y equals 1/3 x plus 3. You can also write it, but you need that information as well as the slope in order to plug into slope-intercept form. I do like point slope form because it gets you right to your answer. There's no re-plugging in of values. It's just you plug in your point, you plug in your slope, you rearrange it, and you've got your slope-intercept form. That's why I like that so much. So anyway, here you go. This is the end of our lesson on example 5. We wrote a parallel line given a point and the line that it's parallel to, so we knew we had to glean that slope and use it in our answer. And then we also wrote a perpendicular line given a point and a line of that's perpendicular to our new line. So if that did not make any sense, I'm so sorry. Please rewind me and listen to it again. Otherwise, write your questions down and bring them to class. Thanks for listening.